All right, so let's dig in. We talked yesterday about the area formula for a circle because we used it several times. Does anybody remember what the area formula for a circle is? Pi r squared. Area equals pi r squared. And what does the r stand for? Radius. Awesome. Let's look at number 1 here. It says find the radius of a circle with an area of 117 square feet. So we know our area formula is area equals pi r squared. We're going to take this 117 and put it in the place of a. So 117 equals pi r squared. You are going to need a yellow calculator for this, so if you do not have one, please go and grab one. In our quest to get the radius r by itself, we're going to first need to get rid of pi. What operation is connecting pi to r squared? Multiplication. So how are we going to undo that? With division. We're going to divide by pi. So 117 divided by pi, what does that give us? 37.242 is equal to r squared. Do we want r to be squared? How do I undo that? Square root. So now we're going to take a square root of 37.242. If you do it to one side, you got to do it to the other side. The squared and square root cancel out on r. And what are we left with? 6.102. Should we put units with that? Yep, we should. Is it area? Then it's not squared. It would just be feet. The area has squared units, but the radius does not. Only area gets squared units. But yes, if there are units given in the problem, you do need to give units for your radius. Or, as in number 2, it says find the diameter. So we're going to need to give units for the diameter of this circle with an area of 15 square inches. So I'm going to start off with my area formula. Area equals pi r squared. We're going to put 15 in the place of the area. So I have 15 equals pi r squared. And then what do I do? Divide by pi. On both sides, we're going to divide by pi so that we can make it cancel out over on the right. 15 divided by pi gives us what? 4.775 is equal to r squared. Now what? Square root. If you do it to one side, you've got to do it to the other side. We're doing this to get rid of the squared on r. Squared and square root cancel out over on the right. What is the square root of 4.775? 2.185 is our radius. But were we asked to find the radius? What were we asked to find? Diameter. How do you find the diameter if you know the radius? 2 times the radius. So diameter is equal to 2 times 2.185. And what do we get? 4.37. What units should we put with that? Close. Is this area? Then it does not get squared inches. It would just be inches. No squared units unless what you have found is area. All right. I would like for you guys to do number 3. Number 3 is like number 2. You've been given the area and you've been asked to find the diameter. So I'm going to give you guys about 2.5, 3 minutes to do number 3 on your own. Yes, it is. You're welcome. Nice job. So I've already substituted in the 1493 in the place of the area. What do I need to do after that? Divide both sides by pi. What is 1493 divided by pi? 475.236 is equal to r squared. And then what do? Then we square root. If you do it to one side, you do it to the other side. Squared and square root cancel out on r. So what is r? 21.799 is equal to r. So my diameter is 2 times r. The diameter then would be 2 times 21.799. What is 2 times 21.799? 43 point, you said 599? 598, thank you. What kind of units should we put with that? Miles. Just miles. Again, if what you found is area, then at the end you would put squared units on your answer. If what you found was something other than area, then it does not get squared units. Very good. All right. Let's look down at the next section, these 3 bullet points here. We need to get 1 definition and 2 formulas written down. A sector is a piece, or you could think of it as a portion or slice of a circle. So I've got a picture of a circle over here. I'm going to draw in 2 radii. So this right here would be a sector. It's a slice of the circle, piece or a portion of it. To find the area of the sector, we're going to use the area formula for a circle, except we're not looking at the whole circle. We're just looking at a piece or a fraction of the circle. So we have area equals the fraction of the circle that we have times pi r squared. Or another way to think of that is if they have given us an angle for our sector, we take the angle divided by how many degrees in a full circle? 360. So the angle of our sector over 360 would be the fraction of the circle that we're looking at times pi r squared. So this would be my area in here. The arc length is the portion of the circumference for a sector. So this right here, kind of like thinking of it as the crust. Here's my arc length. Because it is a portion of the circumference, we're going to use the formula for circumference, except again, instead of looking at the whole circle, we're just looking at part of it or a fraction of it. So I would take the fraction of the circle that I'm looking at times 2 pi r. Or again, if we have an angle for our sector, then we would take the angle for the sector over 360, that would be my fraction, times 2 pi r. All right, let's look at number 4 now. We're going to find the arc length and the area for each of these sectors. And for parts A and B, that means the shaded region. So let's find arc length first on part A. So I'm going to abbreviate arc length AL equals fraction times 2 pi r. All right. So in order to use this formula, what's the only piece of the circle that I need to know? I need to know the fraction, and I need to know the radius. Sorry, I need to know 2 things. Those are the 2 pieces that I need. So did they tell us how many pieces the circle was cut up into, or did they give me an angle? They gave us an angle. So we're going to use that angle to write our fraction. It's going to be the angle over 360. How big is that angle? 60 degrees. So 60 over 360 times 2 pi times our radius. How big is our radius? 8. So 60 over 360 times 2 pi times 8 for our arc length. Now I'm going to grab my calculator and I'm going to type it in just like that. I'm going to use the fraction button for the 60 over 360. So the fraction button is right here. Alternatively, you could put parentheses around your fraction and use the division key. What do we get? 8.377 is what we get for the arc length. Do we need to put units with that? Nope, they didn't give us any units. So you could write down units, or you could just leave it as 8.377. All right, so there's the arc length. Now we need the area. Area for a sector is the fraction times pi r squared. My fraction stays exactly the same because my angle stayed the same. 60 over 360 times pi times my radius of 8 squared. And then I take that and I type that into my calculator. 33.510 or 0.51. If there's a 0 in that third spot, I usually just don't write it down, but there's nothing wrong with writing it down. And that would be units squared. Let's do one more like that together, and then I'm going to have you guys try part C on your own. So the first thing we're going to do is arc length. Arc length equals fraction times 2 pi r. What is my fraction this time? 210 over 360 times 2 pi, and then what are we putting in for r? 18. So what is the arc length then? 65.97, and then I just didn't hear that last digit. 3, thank you. 65.973 units. Area is equal to our fraction times pi r squared. I'm going to have to keep this from getting into part C. What is my fraction? 210 over 360 times pi times 18, my radius, squared. What is the area? 593.761 units squared. Thank you. That is perfect. All right, I would like for you guys to try part C on your own. What is the fraction on number 7? 100, because it's 100 degrees out of 360. So 100 over 360 times 2 pi times, what are we putting in for r? 7. So 100 over 360 times 2 pi times 7. What does that give us? 12.217. Should we put units with that? What units should we put? Centimeters, yes. So there's our arc length. And then the area fraction would be 100 over 360 again, times pi, times the radius. How big was the radius again? 7. Radius of 7 squared. So 100 over 360 times pi times 7 squared. What do we get? 42.76 units. Centimeters squared, because that is area. Very, very nice. We've got one last problem to look at, and then that actually finishes up everything that you need to do that last homework assignment. That's going to complete all of our new material. A circle with diameter of 24 meters. Ooh, I'm going to highlight that. That seems like it would be important. If the diameter is 24 meters, then how big is the radius? 12 meters, half, right? And it's divided into 16 equal sectors. So 16 equal parts. Thank you so much. Sixteen equal slices. Find the arc length and area of each sector. The arc length and the area? No. Yes, it's going to be the same for each of the sectors on here, but we need to figure out how much that is. If I say find out the arc length and area for each sector, how many are we looking at a time? 1. Out of 16. So what would my fraction be then? Yep, 1 over 16. This is my fraction. All right, so arc length is equal to fraction times 2 pi r. Area is equal to the fraction times pi r squared. And instead of using the degrees for the fraction, because they just told me how many equal-sized parts they have chopped this circle up into, we are going to use 1 out of 16 as the fraction, times 2 pi times, what did we say the radius was? Radius is 12. So let's go ahead and pop that into the calculator. 1 over 16 times 2 pi times 12. 4.712. Should we put units with that? What units? Meters. All right, and then we have area. We're still looking at 1 out of those 16 pieces, so my fraction is still 1 out of 16 times pi times the radius of 12 squared. 1 out of 16 times pi times 12 squared. What do we get when we do that? $28.27. What was the last digit? 4. Thank you. What units should we put with that one? Meters squared. Yes. All right, let's see how part B is different. We still want to find the arc length and the area, but now we're looking at how many sectors? We're looking at 14. 14 out of how many? Out of 16. So what's my fraction? 14 over 16 is my fraction. So other than that, it's exactly like part A. My arc length is the fraction times 2 pi r. So the arc length would be 14 out of 16 times 2 pi times my radius didn't change size. The radius is still 12. What do we get for the arc length? 65.973 units. Meters. And then area is equal to the fraction times pi r squared. So my area would be my fraction, 14 out of 16, times pi, times my radius of 12 squared. What is the area? 395.84 units. Meters squared. Absolutely wonderful. All right. Like I said, that actually finishes off absolutely everything that you need to know in order to be able to do that third homework. The third homework is due on Monday. Third homework is due on Monday. Tomorrow, we're going to review all of the formulas that we have used, and I'm going to highlight which ones I will give you on the test so that you know very clearly which ones you need to memorize for the test. And if you're struggling to memorize these, then I would recommend making flashcards with the shape and the name of the shape on one side and the formula on the other side. Yep, give me just a second. There we go, due Monday. You said I was going to be 16. No, right here. That's where the 16 came from. Oh. However many parts it has been cut into is what your denominator will be. Yep, so if it's been cut into 4 equal parts, then your denominator would be a 4. If it was cut into 20 equal parts, then the denominator will be a 20. You good, Mary? You're welcome.